So let's do some examples. So determine if the series converges or diverges, and if it converges, find the sum. Okay, so basically what we're doing here is we're summing an infinite amount of numbers, and we want to know whether this is going to converge or diverge. So remember that in order for me to know if it converges or diverges, and all we need to see is whether this geometric series, the value of r is less than 1. So that's basically what we're looking at. So this is the important thing. So let's find out what r is. So here you can also already see it from inspection that this is probably going to diverge, but let's go ahead and test it. So let's first find our common ratio. It's going to be a2 divided by 1. So 4 divided by 2 equals 2. Notice that r is greater than 1. Okay, because it's greater than 1, this diverges. So basically, if I were to add in all of these numbers, it's just going to go to infinity. Okay, so we're done. We don't need to find the sum because it doesn't converge. And now this next one, let's go ahead and find first the common ratio. So we're going to take a2 divided by a1. So that's going to be this negative. So don't forget about that negative. Negative 8 over 3 divided by 8. Okay. So if you take this, what is this going to give me? This is going to give me 1/3. Okay, so negative 1/3. Okay, and now what you want to do, remember, we're looking at the absolute value. So we want the absolute value of r. So it's going to be the absolute value of negative 1/3, which is 1/3. This clearly is less than 1. So this converges. So this is going to converge. Okay, now because this converges, we want to find the sum. So the sum, if we go back, the sum of an infinite amount of numbers is going to be this formula, s sub infinity. So we're going to write s sub infinity is equal to a over 1 minus r. A is the first term, which in this case is 8, divided by 1 minus r. R in this case is negative 1/3. So I'm going to get 8 over 4/3, which is going to give me 6. So basically, when I keep adding these numbers an infinite number of times, this is going to get closer and closer to 6. So basically, what's going to happen is that you keep adding 5.999999999. So it's getting closer and closer to 6. So you're basically finding a limit. Now, something that we've kind of been doing is that we've been writing down all of these series, like kind of the long way. So we kind of want a shorthand notation. We don't want to be writing them over and over again. And a lot of us have seen this summation notation already, because when we've done integrals and approximations, we've seen the summation notation. So the summation notation is basically an easier way to write the series, and we usually use the sigma notation. So if I were to write sigma or summation from I goes from 1 to 4 of 2 to the ith power. Well, this basically means that the bottom thing tells me when I'm starting. So I'm starting at 1. And then this one tells me when I'm ending. I'm ending at 4. So the first number that I'm going to plug into the I is going to be this 1. So I plug in the 1, so I'm going to get 2 to the first power. The summation just means add. So now I'm going to add the next number. So after 1 is going to be 2. So it's going to be 2 to the second power. Okay, not at 4 yet. So I'm going to add the next number, which is 3. That's going to be 2 to the third power. And then I go to the next one, 2 to the fourth power. And then I end. So this is my first, second, third, and fourth one. So this is how the way that we write out the sequence, the series. Okay, so let's say we wanted to do another one. Let's say we had the summation from k goes from 3 to 7 of 1 over k. So in this case, what we want to do is start off with k equals 3. So we're going to start off with that one. That's my first term, 1 over 3. Add, then go to the next one, 1 over 4. Next one, 1 over 5. Then the next one, 1 over 6. And then the last one, 1 over 7, because that's when we want to end. We want to end at 7. Okay, so this is going to be the entire series. So notice that this notation is much easier to use than just writing everything out. And it's actually better because sometimes we can have something that looks like this. N goes from 0 to infinity of n plus 1. Let's say 1 over n plus 1. So notice a couple things that you don't necessarily have to have an I. It can be anything that you want. It can be I, it can be K, it can be N, it can be anything, any letter that you want. What you want to do here is that you want to first start off with 0. So 1 over 0 plus 1. Then I'm going to add it, and I'm going to plug in 1. 1 plus 1. Then I'm going to continue 1 over 2 plus 1. 1 over 3 plus 1. And typically what we do is we just write little dots to kind of symbolize that that's going to go to infinity. Okay, so writing it out, not too bad. Okay, it's pretty standard, but just so that you're aware of what exactly the summation notation was, or if you forgot. Okay, so we're going to do a couple of examples. Okay, so here's my first example. So write each function. Oops, that's wrong. No, write each function. Write each infinite series in sigma notation. Beginning with the sum from I goes from 1 to infinity. Okay, so that's how you want to start it off. So we're going to do the first one. So we have 1/3 plus 1 over 9 plus 1 over 27 plus 1 over 81, and then we continue. So the first thing that you want to do is you want to write your summation notation like this. That's how you kind of want to write it. We want to start with 1 and then go to infinity. Now, one of the things that you got to do is you got to look at the patterns. So you can see first that if I look at every single term has a 1 on the top. Okay, so basically the sum should start off with a 1 on the top. Now, what about the second one? Okay, so the thing on the bottom. So you can see that you see 3, then 9, then 27, then 81. What do all of these have in common? Well, that's just 3 to whatever power, because if I do 3 to the first power, I'm going to get 3. Then when I do the second one, 3 squared is going to be 9. 3 cubed is going to be 27. 3 to the fourth is going to give me 81. So it's going to be 3 to the power. So in this case, it's going to be I. So 3 to the ith power. Okay, now let's do another problem. Let's say we had -1 plus 2 minus 3 plus 4 minus, and so on and so forth. Okay, so first let's start off with the sum from I goes from 1 to infinity. Okay, so the first thing that I see is that I get the numbers 1, 2, 3, 4. Okay, so I continuously see that. Well, that's just where it starts. That's perfect because it starts with 1, then 2, then 3, then 4. So that's just going to be I. Because if I plug in 1, I get 1. If I plug in 2, I get 2. If I plug in 3, I get 3. If I plug in 4, I get 4. Okay, so it's just I. Now, what are we going to do with these negatives? Now, I can't just add a negative there because then the second time has to be positive. So this is actually a -1, okay? If I take this -1 to the first power, it's going to be negative. If I take this -1 to the second power, it's going to be positive. Okay, so let's just do it to the power of I. Okay, and typically, whenever you see alternating stuff, like a negative, a positive, a negative, a positive, whenever you see that pattern, the best way to kind of write a formula for that is just -1 to the power of n, or I, or j, or whatever it is. So this is the key to that. So whenever you see an alternating power, or an alternating series, you kind of want to look at that. Okay, now let's think about geometric series and how you can write them in summation notation. Okay, so when we think about geometric series, we can write these geometric series the following way. So we know that your geometric series is just a1, okay, plus a2r plus a3r squared plus a 4r to the third. I don't know why I had that brain fart. Okay, so then we have a n r to the power of n minus 1. Okay, so how can you write this as summation notation? Well, this guy is just going to be equal to the sum of a. Okay, so we have a there. Okay, so it's going to be a to the nth power, or a sub n. Okay, so that's just going to be going from 1, because notice that these guys don't change. Okay, there should be a 4. Okay, keeps going. And then r is going to stay the same. And then you just have an n minus 1. Okay, because everything is 1 less. Okay, so we start from we're doing n. So it's going to start from n equals 1 all the way to infinity if I want to go all the way to infinity. So this guy is basically the geometric series. Okay, representation of the whole thing. So instead of writing everything out, we know that this is what it's going to be. Now we know that this guy is always going to be the first term, so we can write it like this. We can write it as the sum from n goes from 1 to infinity of a r n minus 1, where a here is going to be the first term. R is just a common ratio. Let me just write it as CR, and then n is the number of terms. Okay, so if we have a summation notation and we identify it like that, then we know that it's going to be geometric series. Okay, so let's do an example using geometric series. Okay, so determine whether each infinite geometric series converges or diverges. Okay, and then if it converges, then what we want to do is find the sum. Okay, so let's start with part A. So with part A, we have the sum from I goes from 1 to infinity of 100 over 5 to the I. Okay, so if we kind of look at this, it told us that this is a geometric series, okay? But let's try to make it like this, okay? Like this guy, okay? So a couple things is that the only thing that has a power is the I. So I have the sum from I goes from 1 to infinity. One thing that I can do is let's move the 100 over. So I just have 1 over 5 to the I. So just moving the 100 over, we know that there's a 1 on the top. Okay, now what I can do is I can factor out that I. So I write it like this, so 100, and then I have 1/5 to the I. Okay, because remember, 1 to any power is still going to be 1. So if I plug in an I, it's not going to do anything. It's still going to be 1. Okay, so now we're almost there. So this guy kind of almost looks like this guy. The only thing that we need is this n minus 1 thing. Okay, so how are we going to do that? Well, let's go ahead and get rid of 1. So we're going to write summation from I goes from 1 to n, or 1 to infinity of 100. Let me go ahead and strip out a 1/5. So I stripped out 1/5, and now I have I minus 1 left. So I took out one of them. Okay, so then when I multiply this out, I get the sum from I goes from 1 to infinity, 100 over 5. Okay, that's just going to give me 20, and then 1/5 I to the minus 1. So now this looks like just like that. So we can immediately see what A, R, and N is. So A in this case is going to be 20, and then R is going to be equal to 1/5. Now because 1/5 is less than 1, we know that this guy is going to converge. Okay, so it converges. Now all we got to do is just find the sum, because if it converges, let's find the sum. So we have S sub infinity is equal to A over 1 minus R. A in this case is equal to 20 divided by 1 minus R, which is going to be 1/5. Okay, and now this is just going to give me 25 when I put this in the calculator. Okay, all right, let's do another one. Let's say we have the sum from J goes from 1 to infinity of 5 times 2J over 3J to the power of J. Okay, so one of the things that I can do is I have the sum from J goes from 1 to infinity. Okay, so I can see that these J's are kind of together. I'm going to move the 5 over because the 5 isn't doing anything. And I'm going to factor out the J exponent. So I have 2/3 in there. Okay, now this doesn't quite look like the geometric series. So what I'm going to do is I'm going to factor out a 2/3. So I'm going to have the sum from J goes from 1 to infinity, 5 times 2/3. And here I'm going to have 2/3 to the J minus 1. So what I'm left with is just a sum from j goes from 1 to infinity. That's going to give me 10 over 3. And then I have this 2/3 j minus 1. Okay. So now all we're going to do is we're going to have the sum s sub infinity a over 1 minus r, okay, if it converges, which it actually does, because if you see here, this is my value of a, so a equals 10 over 3. My r equals 2/3. This is clearly less than 1, so this converges because the r, so it converges. So when we try to find our s sub infinity, a is going to be 10 over 3 over 1 minus 2/3. And that's just going to give me 10. So that's the sum of the infinite terms. And now let's do this last one. So n equals 1 to infinity, negative 2 to the n. So I can do the same thing. So I can take out a negative 2, strip it out, and I'm left with n minus 1. Okay, notice here, this is my r is equal to negative 2. I need to take the absolute value of it, which is going to be just 2. Well, 2 is greater than 1, so that means that this guy diverges. Okay, because it diverges, we know that this is either going to go to infinity or negative infinity, so we don't have to check.